Start.
All right, good afternoon. Thanks for coming back after lunch. So first of all, a few logistical things. Anybody who needs a certificate of attendance or whatever, please send me an email actually, that's the easiest. And also remind me, but normally I respond after a while to emails, so you should be good. But if you need it, just tell me. Then what else? That's it for the time being. So let's come to the technical part of the second half of the day today. Very grateful for our next speaker for having come over such a long way, really, of coming over to Barcelona and presenting a very unique view of Femtocell history, developments, and future trends from a Femto-Forum point of view. And I'm proud to present Prabhakar, who is a senior principal engineer at InterDigital Communications in, and listen to this, King of Prussia, Pennsylvania. Okay, this is where he came from. Yes. So he has an enormous experience in designing wireless systems, corroborated by a lot of publications, but also a very rich patent pool, book chapters, books. He's the man who knows really about interoperability between different standards, including wireless LAN, cellular, etc. So you have played a very crucial role in the development of that. And we will be looking forward to your view about what Femto-Forum has to say on the Femtocell development. Thank you very much.
Well, thank you very much for that introduction. I used to believe all that Misha would write and tell me before, but now after that introduction, I think I will be a little guarded in what I believe in what he says. But many thanks to Misha and also Thierry for giving me this opportunity. I truly think it's an opportunity. And it's never a long way to come back to Europe. It feels like homecoming because I did my PhD in Delft University here, so coming back to Europe is always nice. So, okay. So as Misha mentioned, my primary appointment is with InterDigital, but I also have been associated with Femto-Forum for some time now, where I am the vice chair for the networks group, and also have been the lead for the so-called integrated Femto-WiFi networks work item. So what I want to do today is to give you an overview of a very little bit about Femto-Forum, but give an overview of some of the major activities we were involved in, primarily in 2011, and a little bit into what we are planning to do in 2012. I'll go into the organization of the forum and so on, but the groups I thought will be most interesting to talk about are the radio and the LTE groups, which I kind of clubbed them together, and then the networks group, and then a services group, which is actually becoming, has been very active during last year. So Femto-Forum, as probably most of you know, and so I won't spend too much time on it, but I do want to mention the focus of Femto-Forum is all small cells that are using licensed spectrum and are managed by the operator. What it implies is that that we deal with not only residential deployments but also enterprise and metro and rural. So sometimes this span of coverage, if you will, of the forum is not fully appreciated, so I wanted to make that clear. Thanks to Thierry, I can cut down my slides by 2 because I think he's gone through these before, about 66. operators and 69 technology providers. But I think the general message is that there is a good coverage of operators and technology developers. The scope of the forum is, as I mentioned just a while ago, spans residential, enterprise, metro, and rural. Rural is somewhat new addition to our scope, but the other three have been. Now, residential, of course, was the original focus of the Femtocells, and but in the last 2 years, I would say a lot of work has been going on in the enterprise and metro, and I'll talk more about that. So within these deployment scenarios, there are several topics that we address. I won't go through all of them, but say, for example, of course, operator acceptance. I mean, the purpose of one of the purpose of forum is to serve operators, educate them and clarify on issues that they're concerned with. That's one part. The other part, of course, is technology development and perhaps driving standards as well. Right? So in that spirit, operator acceptance is an important element. So now this is an interesting one because originally Femtocells were, of course, designed for coverage extension, right? But more and more offloading, is a functionality that Femtos provide, and so there is focus on that. And then services, as we heard earlier from theory, it's one thing to just get a box for providing the same coverage you get as outside, but it will be nice if these Femto boxes can provide additional value-added services. So things like that. Going in here, it's kind of pretty much the same, but enterprise awareness is an important one, because there are, in enterprise you have the IP PBX, you have the unified communication servers, and of course the presence of firewalls, and so all these things, if the Femto is aware that it's operating in an enterprise environment, some of these can be brought in. Metro, rural, again, here the backhaul becomes a major issue, and so that's something we start to look at, both wired and wireless. Mobility management, right? Again, a very important element which is not so much present in the other scenarios between layers. There is the macro and the Femto layers. And rural, as I said, is somewhat new, so we're just beginning to build up the use cases. And satellite backhaul, of course, is something very special and unique to rural environments. And by the way, rural has a big application in the US, you may or may not appreciate it, but the country is so huge, and there are a lot of rural areas and very difficult to reach areas too. And so that's part of the reason why in the morning's presentation, theory was showing there are so many small operators that you don't hear about. It's AT&T and Verizon that provide nationwide coverage, but there are many Alaska, networks and things, and there's a small operator in northern Wisconsin. So it's not easy to provide nationwide coverage in the U.S. So this is very important, relevant for U.S. too. Yes.
Roaming agreements in place between them?
Yeah, most of these do. Yeah, absolutely, yeah. So sometimes, that is true.
Does this roaming agreement come from the enforcement from regulatory authorities?
I think it's more business driven. Yeah. So this is the overall structure, how the forum is organized, again, as you may know. So we have these standing working groups, first one looking at marketing, second looking at radio, third looking at networks, and then the regulatory aspects. And then as needed, we create special interest groups. And typically these also, for one thing, they come and go as the need arises. But the second thing is they cut across these various groups. So for example, if you look at IoT or even services, there are aspects, in the marketing side, there are aspects in the radio side, and so forth. So, and then of course we, prefer not to operate in isolation. So we do try to reach out and liaise with organizations such as, for example, GSMA for the APIs, WFA and WBA. These are the Wi-Fi alliances, and we've been very active last year in reaching out and making those connections, and we'll only see more of those this year. So as I said, from within this, I'll talk first about radio and LTE groups. most of the time when I go to the meetings, I spend, time in the networks group because that's where, I have to, entertain my audience. But so I kind of gathered, some information which I thought would be interesting. If you ask a very difficult question, I may not have an answer. So in 2011, well, let me start. As I said, prior to 2011, a lot of focus was on the. Of course, if you go back historically, I think originally it started off by standardizing the IUH interface, right? Because these femtocells were just being designed, and they had many different architectures, and there was a lot of fragmentation of thought there. So I think the forum took a leadership role and defined this IUH interface, and that was the, I think, claim to fame, really. Once that got standardized in 3GPP, then I think the focus of the forum changed a little bit more into the marketing and the evangelization kind of a phase, and so IUH interface is one. Then they also looked at the as the femtocells were getting more deployed, interference management is a natural important element. So a lot of work was done, and some good white papers were brought out. That was all prior to 2011. But the interference management studies were, again, and as everything else, was focused in the residential context. So now you begin to see that you're going actually beyond that. So 2011, a lot of good work was done in enterprise deployment. Enterprise is different, as I mentioned, because it's large area. There are multiple femtos. So it's the first time that you're beginning to see multi-femto networks, and a lot of that, what we heard this morning, touches on topics that I'll talk about. Open access, so deploying them in an open access mode in metros was another focus area, and both those activities produced white papers, actually, fairly detailed work papers, white papers. API development. Now, this is, some of you may be familiar with it, but, Femto-Forum also defined APIs so that you can have different software from different vendors on different silicons. Okay, so by standardizing those interfaces between the silicon and the software, the equipment vendors have the freedom to do the best that they can do. So they call it FAPI, and I believe actually tomorrow there'll be a press release, saying something like about 12 operators have apparently adopted, I'm sorry, not operators, 12 vendors are actually adopted these FAPIs, and then they're building products to that. So that's a big testament to the success of it. Also in the EU projects, apparently there's one called LENA, L-E-N-A, and just I read a little bit that they use these FAPI interfaces as well. Synchronization and location, these are important aspects, and there was a lot of work done there. Wi-Fi, more from the coexistence of the Wi-Fi radio and the Femto AP, was also a work item. And again, I will talk more about this later on, but I just want to give you the headline description. Other radio interface, radio existence. The other really means here GPS, and you see. So again, not too much has been done, but I do want to mention that the forum is also looking at those kind of other radio coexistence issues. Going into 2012, the major focus is on what is called multi-standard. You can also call it, sometimes we call it multi-technology, sometimes we call it multi-RAT. But basically it is a single box that has a 3G, 4G, and possibly Wi-Fi, or most likely Wi-Fi in it. Okay? So if you're building a box that has all these three, there are a lot of things that you can do. Okay? In terms of, at a minimum, you can look for synergies between these modems and exploit that. There are commonalities you can exploit on the backhaul, and and then you can begin to integrate these modems at at the AP level, and then bring in new functionalities. So a very major item. And also we call it small cells at this point because some of these issues are common for residential, metro, and enterprise. Right? Now, LTE is small cell product, so it kind of leads into the next item, which is, right now, home eNode Bs, there's one specification for home eNode Bs. But the forum thinks that because LTE is such a flat architecture, right, there's really no difference between a home eNode B versus, the macro eNode B and so on, right? Mainly because the RNC function is collapsed with the Node B function. So when that is the case, it's desirable to define different product classes. An LTE eNode B for metro deployment versus one for residential. So the forum started to try to get some consensus among operators and vendors and try to define these 4 different LTE classes, and perhaps once that is all done, we'll take it to the 3GPP and have it. And of course, the purpose of doing something like this may be partly to define and clarify the market, but there are other advantages too, because once you define different product classes and the AP informs the core network that I'm type 1, I'm type 2, then you can probably do smarter things in terms of radio resource management and so on. So there are technical benefits as well. Synchronization continues to be another item here, but this time more on the LTE TDD focus, which also was mentioned this morning. And also the other thing is the backhaul. And also was mentioned this morning that, more and more we're finding that it's important to take the backhaul properties into account when you do the overall system design, whether it's QoS or whether it's timing jitter, whether it's lack of reliability, what have you, right? So that's that. Lastly, X2, again, very important element. Again, a natural consequence of the fact that the RNC is now collapsed. And also in LTE, there is no Femto gateway. I mean, at least it's not mandated, right? So you have a bunch of these eNode Bs, and at least in theory, there's no central node that manages these things, right? And so the reliance on X2 is very great, and so that item.
On all these aspects, Femto-Forum produces white papers consisting of recommendations, or
yeah. So the output of Femto-Forum is a couple of different types. See, so one are white papers, which are for educational purposes, right, for the operators, say for example in the enterprise we came up with a deployment scenario. So it gives very specific recommendations for the, then that's one type of document. The second type is standards. As I mentioned, IUH was a 3GPP contribution that came from Femto-Forum, I believe, and this was before my days. But so there you have, the output being a standards thing. The third is APIs. If you look at the Femto APIs, these are not standardized. APIs are generally never standardized by any standards body, right? Because they're all interfaces within a box, but they help the industry. So, so as I said, if 12 vendors are implementing to this FAPI, that's a so that's the other type of output. Okay, so a little bit on the enterprise Femto, right? Just going back, I mean, the key thing, of course, is that when you are talking about enterprise deployment as opposed to residential, you're dealing with many Femtos, right? So that's the main point. So different categories, just for convenience, small, medium, and large, and 1 to 5 subscribers, or 6 to 100 for medium, and then large is above that. And you can also translate it into the geographic area with some rule of thumb. If you say about 250 to 500 square feet per person, you can multiply the two and then get a sense of what is. I mean, if nothing else, these are parameters that you can agree on for simulations, for example.
Prabhakar, can I ask you very quickly?
Sure.
What worries the Femto manufacturer most? The number of subscribers or the density of Femto cells? What is the driver number one? You come to that. Okay.
So for example, there are multiple dimensions to it, right? So how is really enterprise different from residential? There are several aspects to it. One is the inter-femto interactions, right? and of course, the more dense they are, the greater is the interaction and interference. The second is the large coverage area per femtocell, right? So typically these are higher power APs, okay, reaching out. Then larger number of users per femtocell, right? Typically for residential, we say it's 4 to 8, but for enterprise, we say it's between 8 to 32, okay? And in rural, it's 32 to 64, like that, right? So that's another parameter. And again, there seems to be some convergence in the general understanding of these terms and these numbers within the industry. Higher user mobility, I mean, it's still not, of course, we're still talking enterprise, so it's at most pedestrian, so it's 3 kilometers per hour kind of speed. And in simulations, even when we simulated a stationary user, we assume, I think it was 0.86 kilometers per hour because of the environment changes. Okay. Then RF variations within enterprise is kind of interesting. So the idea is that because the enterprise is very large, right? If you look at the macro interference, that will vary a great deal within the geographic region of the enterprise. Now, what that means is that at least one implication of that is what the base station, what the Femto AP sees and listens can be different from what the UE is actually experiencing, right? And this is important because Femtos, they use network listen function. So they listen to the environment and they think this is what the UEs also listen and then make some decisions on their own, right? This is the whole autonomous operation. But you see that can break now because the UE is really seeing a different signal level than what the AP is seeing. Smaller path differences. So because the enterprise is, the coverage area is big, what it means is that the UEs will end up having to transmit at higher powers, right? Because the distance is larger. What this, sorry, let me step back. Basically, because the enterprise area is larger, the path loss between the AP to the UE will also be larger. So in that sense, if you compare it to a macro to a UE in the building, the differential between the two path losses becomes smaller. So the Femto UE will begin to see similar radio environment as a macro UE. What that means is that the power levels will be more comparable. What that means then is that the Femto UE will cause greater interference to the macro than in a pure residential case. Yeah. Okay, let me, so, yeah, what I'm saying, what I meant to say here is this. Because the enterprise coverage range is high, right, the path loss between the AP and the UE will also be high. So it gets to be closer to the path loss between a macro base station and the UE. What that means is that now in the uplink, the UE transmit power will be more comparable in the two cases, which means that more interference. Yeah, it's a couple of steps, but any other questions? So just to give a sense of, and again, as I said, there is quite a nice report for Femto members, you'll have access to it. But some highlights, so they simulated a very large enterprise building consisting of 7 floors, 42,000 square feet, about 100 office rooms per floor with the hallways, conference rooms, labs, and everything. And it was operated in a closed subscriber mode and at 21 megahertz, 2.1 gigahertz, and 10 dBm kind of thing. Right? So, it's all within a building. And so, it's not like a university campus where you're going from, building to buildings. But so the idea of this white paper was, if an operator is trying to do such a deployment, what are the things that he has to? How can the Femto-Forum help them? Provide some guidelines. Yes. No. Multi-Femto. So, yeah, multi-Femto is a key aspect of enterprise, at least the way we use the term. When you say enterprise, you can almost imagine it's a multi-Femto. Yeah.
They're supposed to be covered cooperation in them in terms of providing the coverage in the whole.
Right. So now that's an important, good point, because when Professor Viral presented this morning, we talked about cooperation, but that was a lot tighter cooperation. I mean, you talked about X2 level or even distributed MIMO kind of a cooperation. We're not talking about that kind of stuff, but because you see, you guys are at a more advanced phase in research. So, the forum, it takes what's already been standardized or is in some product form and then is helping how best you can deploy this. So there is coordination, which is the purpose of this document. So in some way, so multiple femtos per floor also. Yeah, exactly. I mean, so some of the problems I indicated before will get solved by multiple femto environments, certainly. Yeah. So some of the considerations when you're planning for coverage is, some will be in your control, some will not be, but at least you need to know. First is the location of the enterprise within the macro. You have no control on that, right? The build enterprise can be very close to the cell site, or it can be at the cell edge. Will give you very different macro interference. So you got to take that into account. And as I mentioned, the macro RSSI, the network listen mode may function differently. And again, if you have a very dense deployment, that problem may disappear. But when you're designing for coverage performance, not only voice, but especially in enterprise, high-speed data is important. So you got to somehow, you would want to provide uniformly high data rates across the entire enterprise, because I don't think that has been that much of a focus up until now. Of course, the usual uplink downlink interference considerations and PSC planning. I think this was also touched upon earlier in the morning. See, the PSCs which identify the APs, although there are a large number of them, 512. Apparently, only 4 to 10 or so are allocated typically for femto application. So what it means is that when you are doing multi-femto deployment, there can be collisions, right? So you got to make sure that you distribute these available PSCs in a way that some kind of a planning of these PSCs should be done. And some, this may not be a big deal for researchers, but, they're important for people who are actually building networks. So, as uniform as possible. And those femtos which are at the periphery shouldn't be too close to the edge, in which case there'll be more macro issues, not too much inside, and things like that.
But how can one set a guideline for placement of femtocells? Femtocells are supposed to be placed in an impromptu manner without any plan.
I mean, see, in an enterprise, I think it's a little different, right? Because, there is an enterprise IT department or so. So it's not, what you said is true in a residential kind of environment. I mean, you just probably put it anywhere and you expect it to work.
If it's beautiful, then some planning.
Yeah.
To put it on a visible place, but it's awkward, then the page.
But the considerations will be different than coverage, But in enterprise, it's a little different. They also looked at mobility a little bit, right? So again, this probably will be familiar to you. So indoor RF propagation basically implies that, most of the time you have a single path, slow fading environment. So the user can sit in a deep fade for a long period of time. So which means that you can have very harsh conditions for voice calls for UEs without RX diversity, right? If you have diversity, then there are other advantages. But so for UEs, now I don't know. These will map to some 3GPP release. I forget exactly whether it's which release it maps to, but So for such UEs, obviously, hard handovers, parameters, and so on should be designed, should be optimized so that you have at least less than 100 milliseconds handover latency for voice. Then they also looked at, if you don't have RX diversity on the handset, you try to provide it from the network side, right? And one way to do it is soft handover, or a faster TX diversity like space-time coding or something. So there was, I don't think these are standardized in 3GPP yet, to the best of my knowledge, but there were some studies that were done. So of course these concepts are familiar to you, but I thought, there were 2 points which I thought were interesting. Based on some empirical studies, they concluded that in a dense office scenario, about 7 to 10% of the area will be, amenable for soft handovers. On the other hand, if it's a somewhat open plan and larger area is available for soft handover, so the benefits you receive from soft handover will be greater in an open environment, in a more sparse environment. But the more dense the femtos, then you might as well not have soft handover.
These figures are based on surveys?
Not surveys. I think based on the simulations they have done for different types of office buildings. Okay, so then the open access small cells. Again, just to give you a sense of what they did. So firstly, the open cells, can be deployed in dense urban or rural. And I won't go through this whole table. It's in the slides for you to look at. But basically, they try to, identify what are the small cell location possibilities, lampposts and traffic lights. Whereas if it's rural, building walls and so on, and then also try to identify, some of the implications, in terms of the macro interference. And one thing I thought was interesting is the second bullet there, that these open access small cells would be used more for offloading than for data offloading than for voice, which is again, kind of makes sense, and an operator might deploy it like that, right? So. Voice you use the macro cell, and use the small cells for data offloading, and of course mobility. I mean, they haven't done too much work in mobility, but that is an important issue, right? And people talk about. So the question is, you want to avoid frequent handovers for a fast-moving user. So how do you avoid that? Well, one is called what they call like stickiness. So you estimate the velocity of the user, and if it exceeds some threshold, you basically let him camp onto the macro cell as opposed to the small cell. So that's in a way avoiding the problem in some sense.
Just a question. In one of the previous slides, there was also mention of satellite. For example, in rural, the Femto-Forum considers satellites to provide a backhaul for Femtocell?
Absolutely, yeah.
Do they specify something, a different interface, or means the same Femtocell? Because for providing a backhaul from satellite, if it's a geo satellite or MEO satellite, they need to have a dish, separate dish, or the same Femtocell with its small dipole antenna.
No. Of course, you need to have a radio for the satellite. So depending upon whether you're using a geo
because the current Femto model is a nice looking small box with dipole antenna at the most.
Yeah. No, it'll probably be
place indoor.
Two units coupled together or something like that.
Something has to be outside.
Yeah. I mean, that is still a new work item. So they're just looking at different options. Yeah. By the way, I should mention that while satellite is an option for rural. Of course, microwave, 60 gigahertz and all this, there are obvious choices for wireless backhaul. But there's also talk about Wi-Fi as a backhaul, okay? And especially imagine a scenario in an urban scenario where you have a lot of small cells, and these are on lamp posts and so on, right? below the rooftop of sorts. Now, clearly you don't have line of sight, so you couldn't use 60 gigahertz kind of technologies. So 5 gigahertz, Wi-Fi is a nice thing. But of course, you have problems of interference and so on, right? So what you probably need is a mesh architecture, right? So if you're using, in general, this is my thought, that if you're going to use an unreliable technology for the backhaul, the way to get around the unreliability or lack of reliability is to use a mesh, use redundancy and alternate routing techniques and so on, right? So that's one. So you have a mesh of this Wi-Fi, and then probably there will be one over the rooftop cell tower, that one of these nodes or multiple of them connect to, and then you're back into the core network at that point. There is at least one, and there are products like this already. Okay, at least one company I know is called Bel Air Networks. They are very big in Wi-Fi, carrier Wi-Fi deployments. So, for example, Philadelphia, the citywide Wi-Fi is all deployed, and I believe AT&T's hotspots are also probably Bel Air. So they have a lot of experience in Wi-Fi for mobile operators. So yeah, if they have products where this small cell has Wi-Fi. It has it has room for Wi-Fi. It has room for cellular, and it has Wi-Fi for backhaulers also. So in the open access context, they again, this being a radio group study, they naturally focused on interference and looked at interference from a capacity offloading point of view, not as opposed to just voice, and of course looked at downlink and uplink. Just some detail on the simulation models that were used. These were apparently taken from the 3GPP specs with the usual 57 cells, intersite distance of about half a kilometer, and a wraparound and so on. Uniform distribution of UEs and small cells. It's kind of an interesting point that if you're thinking about this deployment in a shopping mall kind of a area, the potential for line of sight is greater, right? And as opposed to in an outdoor environment, I guess it's somewhat less, and then so they use some probabilistic methods to model that. Just to highlight or give an example of some of the problems that probably are more unique to this environment is a small cell UE jamming the macro cell. So what is shown here is you have a macro cell, a macro UE, which is at the cell edge, right? And so obviously it's transmitting at high power and is causing interference to a local small cell. And so of course these are all co-channel deployments. So the small cell UE now ramps up its power and thereby impacting all other UEs on the macro cell. So things like this can be important to consider. As I said, they didn't do too much work in mobility, but that will be covered in 2012 actually. So some highlights of this study were that they showed that through their simulation studies that small cells can be very effective for offloading, and that both macro users and small cell users experience improved data rates. The reasons are, of course, that there's a reduced load on the macro network because you're offloading more users onto the Femto. So there's reduced load on that. And then, of course, so there's less interference and so on. So there's macro users get higher data rates. On the other hand, small cell users naturally will get a higher data rate because their range is much less. And again, this improvement was seen both for uplink and for downlink. So the next top. Any questions on that?
So from the coverage perspective, did you see, increased coverage by adding femtocells, or was that a reduction in coverage? Because of course the indoor coverage is improving, but what it's doing to the macrocell is that it's increasing interference, at least in the downlink. So what was the cumulative effect on the coverage due to the, maybe in the more realistic scenarios?
See, we are, at least the work item I talked about was an open access study, right? So in that sense, you're not going to create those islands, right? So see, typically, this was a problem, I believe, right? If you had a residential environment and you're operating in a closed subscriber group, then you have a macro user, but he can't get onto your femto, and those are the kind of problems, right? Now, here it's an open access, so it's like any other, it's really two-tiered hierarchical cell. So in that sense, I don't think coverage is affected.
Okay, I mean, if suppose your macro user is not able to hand off to the femto, if suppose femto is already, serving as many users as it can, so its transmission is basically an interference for macro user.
Yeah. If there are limitations in terms of admission problem, right? I mean, you cannot admit a user because the limit of users. I don't know if that was simulated really. I don't think call it blocking probability. I don't think there was a blocking probability put into the simulations.
Thanks.
It'll be an interesting topic. Yeah. Okay, so yes.
You were talking about the white paper all the time, but could you give us the name so we can easily find it?
Yeah, sure. Again, there are some which are still internal to Femto-Forum, and some which are publicly available. So I'll give you the titles. So if
Okay.
Yeah.
Thank you.
So next, moving on, as I said in the LTE case, the idea was to come up with, because LTE femtos can be deployed in multiple scenarios, the home, enterprise, metro, and rural, they wanted to define, in terms of various parameters, different product classes, partly for the market point of view, but also to help, possibly help the actual operation by declaring its capabilities. Again, I won't go through all the details, but this is how the characterization is kind of looking right now in terms of, you see the four different types in terms of uplink and downlink data rates, but also in terms of the number of users. As I mentioned, the minimum is 4 for residential, 8 for enterprise, and it keeps going like that. Then in terms of RX diversity, we think it's mandated for the enterprise case and so on. Then of course the maximum transmit power is increasing from 20 dB onwards, and the speeds also, they change as you go from residential and enterprise to the hotspot case. Okay, so that's kind of what was done in 2011, and looking forward to 2012, as I mentioned, a big focus is the multi-standard, and as I said, I think, by the way, there was a FCC workshop towards the end of last year that I had a chance to attend, and FCC is definitely pushing for small cell technology with multiple technologies and multiple operators. And their argument is very simple. If these are going to be very small form factor, they're going to be deployed in lampposts and things like that, it wouldn't make sense to have one for AT&T, one for Verizon, one for Sprint, one for T-Mobile, So having and also consider the backhaul, right? Most likely you'll have a shared backhaul anyhow, right, depending on the facility. So I think there is definitely a need and a momentum behind a multi-technology, multi-operator, and this introduced a lot of very interesting research problems, in my opinion, and we'll go through some of those now, actually. And so the first is synergy identification, right? How can you exploit commonalities between these different APs? And I'll talk more about each one of them. Second is the FAPI, what we may call FAPI2. I mentioned that Femto-Forum defined APIs between 3G and 4G file layer and the software layers. Now we want to extend that to the next level, whereby you can integrate Wi-Fi as well. Then the inter-rat mobility. We already showed a slide in this morning, which showed the complexity of the mobility in such an environment, and that's something that we realize also. And in fact, very interesting situations come up now. If all the technologies are in one box, right? You may want to do handovers based not on coverage, but based on other considerations. Maybe the loading on the cells, maybe, right? Or it may be the type of application may run better on one radio as opposed to the other. So it introduces a lot of interesting things, and I have a picture to show that. So the potential synergy areas. If you look at the overall system level, right? One of the things that operators worry about is the management of these boxes, right? Provisioning them and troubleshooting them, and performance monitoring, etc. So now, when everything is in one box, you would like to have the same management system for all of them, right? Gateway components. So most likely all these small cells will end up having some kind of a small. You can call it a small cell controller. You can call it a small cell gateway, what have you, right? But and the reasons are simple, in my opinion. One is there are going to be a lot of them, and number two, they're going to be unplanned to a great extent. Now these are ideal, at least two sufficient reasons to warrant a node that can manage these things, right? So if you do have that, and again, how that gateway components can be shared between these technologies, and then IPsec tunnels. Now small cells will be, again, as typically they'll be in public places and all that stuff. So you'll end up having to use as backhaul not T1, E1 and managed networks. It'll probably go over, some third-party public IP kind of networks. So security becomes a very important thing, and that was also mentioned this morning. Now sharing of, but now you have all technologies in the same box. So in one case you have a IUH interface, maybe if it's 3G, you have a S1 interface if it's LTE, and you have some other IP level interface for a Wi-Fi, right? Each needs to be secured in its own way, right? But now can you come up with some clever way? And IPsec is compute intensive, and it may be not as apparent when you look at the AP side. Even there it is quite intensive, and I understand that there are some vendors at least who don't encrypt the traffic. They only encrypt the control signals. Again, because you want to minimize the cost and power and everything. So IPsec is not a cheap thing, and now when you have these huge number of APs, that's one part on the AP side. Now if they're all going to land on one gateway, imagine the amount of processing the gateway has to do, because it has to do the decryption, right? So they are not trivial problems. Joint radio resource management, pretty obvious. Joint network monitor mode, network listening. Now you have to listen on 3G, 4G and Wi-Fi, all these things. So again, what are the optimal ways of doing that? And again, backhaul, transport network layer sharing also. So next is the FAPI2, right? So shown is an exact, a possible reference baseband architecture for this multi-technology AP. Okay. Again, you'll have slide with you to look at, but mainly you got your cellular baseband and RF. So this, right? So this is your RF and baseband. Now these APIs are defined, and these are already available. This is the one that vendors are implementing to, and now you have your software running on top of that, right? And here perhaps you can include, transmit diversity, small soft handover, X2 support, all these things. Now, but now you also have the Wi-Fi part, right? So the idea is whether it makes sense to have another abstraction layer that rides on top of them. And on top of that are functions that are RAT independent, like local IP access or circuit switch fallback, etc., and then on top of it are further applications. So the idea is that by defining these kind of APIs, number one, you decouple the upper layers from the lower layers, so you can have more innovation. And the second, again, is related to it, is these modems now no longer have to work independently. In other words, not only do they give you the independence to choose your software vendor and the silicon vendor separately, but you can also come up with smart methods of integrating all the modems that are underneath. For example, this data aggregation, right? So there may be some applications where you can actually aggregate bandwidth between 3G and 4G and maybe even Wi-Fi, right? Now, will you require such huge bandwidths? I mean, history tells us that there is no upper limit to the bandwidth you want. Now, that may be a cheeky way to get out of the answer question, but the other thing also is that when you have two links being aggregated, there is another advantage, and that is resilience. See, not only can you add the bandwidths when you need it, but it can also provide you a fail-safe operation, right? And especially that can be useful if you're using Wi-Fi as one of the links, right? Suppose you offload it to Wi-Fi and you find there's a lot of interference, and you want to now current solutions will hand it over to cellular. But if you have both links up and running all the time, you initially put all your packets on the Wi-Fi, and if you're experiencing interference, you can move some of the data over to the cellular, for example. So this kind of smarts can be put in, for example.
As far as I know, for example, in Apple or even in smart Android-based phone, at the moment you can have only one interface switched on.
Right.
And I think it's because of the limitation that in the RF chain, either the amplifier or the oscillator or the converter, something is shared. Means all of the, for cost saving, for having a cheap user equipment, some of the components of the RF chain are reused for all the bands. For example, antenna for them. Antenna is the same for all the bands because it's not bandwidth sensitive. Oscillators have to be different. Amplifier might have to be broadband, but antenna is only one antenna transmitting on all the four bands. So to exploit this data aggregation on multiple technologies, RATs, they will have to put more than one RF chain.
Right. So, I mean, certainly, are the handsets already there to facilitate this? Probably the answer is not, a definite yes. But I must say this. See, Wi-Fi and cellular, I think both radios can be on at the same time, as opposed to 3G and 4G. I could be mistaken, but, in iPhone,
they can be on, but not quad band, or not all four of them, because it comes to the limitation of the oscillator, for example.
I understand. But what I'm saying is, let's say you have one cellular band and one Wi-Fi. I mean, those connections can be on parallel, in my opinion.
Yeah. Two can be on, but for example, with the power amplifier, the big problem is intermodulation products.
Yeah.
If you have such a wideband signal, because it will become effectively wideband signal, you are going from 800 megahertz to 5 gigahertz. So if the amplifier has to process all of them together, then I don't know, means it has to back off a lot.
Yeah.
If you have a single radio, but if you have 2 or 3 radio chains, which I think is the current standard,
Right.
I think tomorrow we're going to hear about a physical layer design which has a single radio addressing these problems.
Yeah, I think what we had in mind was more the multiple, you have separate radio, one radio for Wi-Fi, one radio for the cellular, and then you can do that. Now, going beyond that, it depends on the device development, of course, the other thing I wanted to say before moving on to the next topic is in this discussion, if you look at 3GPP standards, right? There is a set of standards called which deal with Wi-Fi cellular interworking. The first one was called IWLAN, right? and then it became EPC standards, right? Now, in the beginning, the standards addressed seamless handover from one radio to other radio. And they use protocols such as DSMIP and PMIP and so forth, right? That deals with a single radio being on it at any given time, right? You're either on Wi-Fi or you're on cellular. Now, if you look at the 3GPP standards after that, they actually talk about what you can do if both radios are on at the same time. And those technologies are called IFOM, IP flow mobility. And again, they use DSMIP and PMIP as the protocols with suitable extensions. And the extension basically had to do with dual registration or multi-homing, that you need to have two IP connections on it. So the reason I'm mentioning this is that while there may be device restrictions today, at least 3GPP as an industry group has foreseen that these solutions could be worthwhile as we go down, you know. So and I honestly don't think that this is really that undoable, at least between, yeah.
But you need to have multiple chains.
Right.
Yeah, they won't be able to save money saving now in terms of having one chain and then switching it.
Right. Yeah. Okay. So that's this work is likely to go on today, this year. So just to show, you know, what this inter-rat mobility could look like in this environment of multi-technology small cells, right? So you got GSM, Wi-Fi, UMTS, LTE, right? 4 technologies. And firstly, you know, the loading on each of these radios is an issue, right? You want to make sure that everything is balanced. So there will be some processing, some intelligence that has to go in assessing the load balancing. Then there are many other criteria, such as, say for example, subscriber prioritization, right? You may have gold subscriber and silver subscriber and platinum subscriber and so on. So they may have to be taken into account. So for example, a gold subscriber you may leave him on LTE, but you know, a lower paying subscriber may be offloaded to Wi-Fi in case of network congestion, for example. Service prioritization, different, of course, emergency calls and so on will be higher priority, but even within other normal services, you may have a prioritization, and so on. And in fact, you know, so based on all these considerations, you got to make a decision, which is to change the technology or to change the cell or go to the macro, you know, those kind of things. So you see, it's a lot more complex. And I want to say one thing, you know, while it looks complex, in my opinion, there are 4 dimensions along which these handover decisions can be made. The first is location. If you are near, for example, AT&T already does that. If you are near a AT&T hotspot, you offload directly. Right? Second is the user type, as I mentioned, the subscription type. And that can also be actually a user type based upon his usage, because there are some users who are heavy hoggers of the bandwidth, and the operator sometimes they'll throttle that bandwidth. Right? So either user subscription or usage type. The third is application type. Some applications can get higher priority than the others, right? And the last one, and probably the most difficult one, is the network condition, right? I say it's difficult because the knowledge of the network is not present all at one place, and secondly, is not always accessible to the nodes that make the decision as to how to move the flows around. So in that sense, it's a more spread out problem requiring standard changes and interfaces. But at a high level, these are the 4 dimensions that come into play in terms of policies or, you know, that have to do with multiple technologies. So then this is a little bit of a blue skying here, you know, but we're thinking, so if you have a network that's consisting of these multi-technology things, right? And again, remember I think this morning there was a slide that was shown. I think Cisco interviewed a lot of people, and they said, what is your most concern as you go to EPC? and one of them, the first one I remember was coexistence with 3G and existing UMTS core. So there's also a lot of evolution, a lot of differences in the core network. So it's becoming complex, But in some way, if you look at the small cells, you can think of this as a simplification on the RAN side. Certainly, it has made it flat, but also when you put all the technologies together, it can be so. So you can imagine, huge number of these multi-technology APs, and then one macro cell, and that's it. That's your RAN. Okay. So what about in the core network side? You have to still live with all that mess. So here is a proposal that says, hey, what if you have a single mobile core that manages, and this is the key point, only the authentication and mobility, right? No service-related things at all, right? And then use an IMS core to provide all your services. Now, this interface can be on anything, on any IP connection you want, right? So in some way, it looks clean. So this came up because we were asking ourselves, in this world of small cells, multi-technology small cells, what could be the impact on the core network, right? So again, I think there are interesting network research opportunities in exploring these aspects.
Okay. Yeah. Okay. Is there any work group in Femto-Forum which looks at the cloud perspective future of Femtos? Because Femtos can be essentially used to enable cloud. For example, offloading the core network. This is one of the interesting ideas. The other idea is that by caching the user profile, Femtos can locally know that what their users ask for. In that particular home or enterprise.
Yeah, the short
just
answer
like
is
Google. Means, for example, Google is able to search so quickly and provide answer because they have a lot of distributed servers.
Yeah.
So that's example of cloud. So Femtos, from that point of view, is there a work group?
It's certainly interesting and probably relevant too. But right now we don't have any active work item defined to do that. Yeah. But I would just like, for the benefit of everybody, just in case you're not that much into this area, the way I see, there are two extremes. The small cells, as we're talking here, these you can think of them as intelligent, sort of heavy edges. Okay. The other extreme is where you have dumb edges. So that's the remote radio heads, just the antenna, nothing else, right? And then you got all your processing centralized. If you want, you can call that a cloud. Okay. So in fact, ALU, they all call it cloud RAN, right? So these are two extremes, right? And and you can of course then ask yourself, what are the pros and cons? What can this do? What can the other do? And so forth. For example, in the intelligent edge, you can put a lot of smarts there. You can put services. You can put these things. For the other one, the cloud RAN, for example, one of the cons there is the link that you require between the remote radio head and the baseband processor pool. Now, the antenna just does the RF. It down converts it to IF. And then the IF signals are digitized and transmitted. That's a lot of bandwidth. Okay? So, which means that you need fiber. So, that's not cheap. So that's one. But on the other hand, because you are sharing the baseband processing, you can load share between different base stations or remote radio heads in a dynamic manner. So you can cut down power consumption, for example, in these days of green energy, green solutions, right? So there are that kind of advantages. But yeah, so in that sense, I think even in the context of small cells, cloud solutions versus edge solutions do make sense, but like everybody else, we are also staffed for volunteers to do these things. So okay, so I think I have half an hour more, so let me just switch over to the networks group, right? So last year we looked at. Let me talk about the second two, enterprise and open access. So as I mentioned, the radio group looked at the interference and those kind of issues in enterprise and metro, and we were looking at the network aspects. Then the other thing which was which I was driving, and so I know a little bit more about it, is the integration of the Femto and Wi-Fi, and that actually was quite a it attracted a good amount of interest, and also led to interactions with the Wi-Fi standards groups, the WFA and WBA. For those of you that may not be as familiar, someone gave a simple analogy for me, which helped me to understand. See, I mean, basically what this what the respective roles are in a way, right? So you have IEEE, which sets the standards. Then you have WFA, which picks a subset of these features that are standardized and defines profiles and does certification of devices, right? Sometimes they also come up with enhancements which they feed back to IEEE, but essentially it's a product certification thing. Then you have WBA, which tries to reach out and address deployment issues and talk to operators, write white papers for them, and resolve billing issues and roaming issues and that kind of stuff. A bit similar to 3GPP that does standards. Then Femto-Forum that doesn't do certification, but in some sense, does a little bit of this stuff. And then you have GSMA, which is really an operator driven and an organization that is really meant for the operators, for their deployment concerns, billing concerns, security concerns, and so on. Which one?
And NGMN. Where does that fit?
NGMN, I don't know too much about it, but what I do know is that is in the context of backhaul. It looks like they've done a lot of work in backhaul standardization. So that's we are liaising with them from the backhaul point of view, but I don't know their big scope.
Yeah. Now that I'm not sure you're going to talk about this, but it's pretty interesting, the Femto-WiFi interaction, actually, because I worked for France Telecom before. They didn't want to know anything about Wi-Fi.
Right.
And Femto was not exactly their cup of tea either. When you talk to Thierry, now he's gone, I can say it, he doesn't want to hear anything about Wi-Fi either. And now you're saying that actually, that's a kind of marriage between two technologies which could be perceived as competitors at hardcore. I don't see it like this. I see it rather as an opportunity. So I'd like to hear a little bit more feedback. What does the Femto-Forum think about this?
I love your questions, because there's the next slide. Okay. Well, the next slide. Yeah. Just a summary of what we're doing in very important question. I mean, the rest of my talk is almost on that. So what we're planning to do in 2012 is, so integration of Femto and Wi-Fi, we kind of see it as naturally progressing to the small cells, 3G, 4G, Wi-Fi, right? So in that context, being the network group, we are responsible for the system architecture. So for example, the IMS core and the simplified system architecture that I showed earlier would be something that we could build on, The second one is something that at least interests me a lot, edge-based small cells. So, because you put so much intelligence in the edge, now you can do smarts right there. And again, I'm not, paid by Bel Air to talk about them, but that's one product that I've seen, and I was pretty impressed. They have local policies for local offloading, local administration, implementation of security, and things like that. So I feel that there's a lot that can be done, and I have some slides that go into it also. Then the mobility part. Now, the mobility that was looked at in the enterprise networks was in a purely Femto network, right? But now you throw in Wi-Fi, and you have to throw in Wi-Fi because enterprise do have Wi-Fi, right? So what is now the, what are the issues and what are the best ways to manage mobility in a Wi-Fi and Femto environment, especially in an enterprise, which is in a way simpler because at least the Wi-Fi part is controlled locally. And then, yeah, we are talking to WFA, WB a lot more. Then backhaul, has been actually identified as a new work item, and we have a person from BT who is actually driving that. And then security, I don't know whether some of you probably are tracking, but every now and then there'll be some report, of some hack or something, and so Femto-Forum, of course, gives itself the responsibility to respond to these things. So we want to be prepared with a comprehensive study of it. So until now it was happening on an ad hoc basis, as and when there is a need, there would be some response. But now we felt that you need to have a separate work item and constantly track what's going on. So, okay. So about the integrated Femto-Wi-Fi. So indeed, as you said, there was a lot of skepticism, not only in France Telecom, but I believe in general the mobile operator community, that Wi-Fi is seen as a threat. But I think that was years ago, and over a period of time, and now of course operators totally embrace it. Like AT&T does, what is it, 25, 50, some huge, many tens of thousands of hotspots, and they just offload you to the Wi-Fi, and as I said, there are more and more. They call it carrier Wi-Fi now, right? Companies that are deploying carrier Wi-Fi. So it's no longer. I don't think anybody will really ask a question. Neither companies, but even analysts also. Femto-Forum also talks to analysts, and many times the analysts ask the question, right? And but now those questions don't appear at all. It's a question now of how best you can use Wi-Fi and cellular. Okay. So there was a paper, for example. Now, I think there are many benefits for that can be reaped by integrating these two. But at a headline level, this message seems to be resonating well. It's a simple one. It doesn't capture all the benefits, in my opinion. But it's in the context of offload, because everybody understands offload. But what offload does today is what I may call as a gross offload. You take all your data is either on Wi-Fi or on cellular. It's a bulk, maybe not gross, a bulk offload. What we say is that by integrating this, you can do smart and fine-grained offload. Now, smart meaning, again, application-based, for example, usage-based, user-based, and this kind of stuff, right? You can put those smarts, not just on coverage, right? The second is fine-grained. So and I'll talk more about this IFOM, IP flow mobility, which has been standardized in 3GPP, essentially says that you can hand over a single flow from one radio to the other while keeping all the other flows on the first radio. So it's a much more granular, offloading that you can do, and by doing so, you can achieve load balancing, for example. Right? So that's one, headline description. But there are more, I think, that can be done. So that was the original peacemaking white paper. Then there was a work item that looked at, so the Femto-Forum began to say, okay, you know what, we have to start looking at both of them. So the first thing they looked at was, or started to look at, was the RF interference between the two. So if you keep them very close to each other, do they really cause this intermod kind of interferences? And they came up with a test plan, and this testing is going on. It's gone a little bit slower than what we would have liked, but I understand from the radio group that it will be done this quarter, perhaps. But this is happening. There are so many vendors that package these two in the same. There's an increasing number of Femto vendors that put in Wi-Fi in the same box.
So the interference is really because of the spillage.
Intermod.
Yeah. Okay.
Yeah, nonlinearity is an intermod.
Right.
Source, yeah.
And it's a problem. Yeah. People know about it. Oh, okay.
Again, it's well. See, we didn't know whether there was any problem.
Yeah.
So the idea was to come up with a test plan, get several APs, Wi-Fi
Right.
APs, and do some testing and see if there is
Yeah.
any problem, and if so, provide some recommendations.
Right. Okay.
In terms of, it could be in terms of, okay, your filters have to be,
Yeah.
see, especially on the Wi-Fi side, you can imagine, because it is such a consumer product, you know, you can have cheap,
Yes,
filters,
yes,
so
yes,
the
yes,
skirts
yes.
may be very,
Yes, yes.
you know.
That's interesting. Yeah.
But then there may be non-linearities too.
That's good.
So then, as that was in progress,
Further to this, the previous slide means where the smart offloading, you talked about smart offloading.
yes,
That means this marriage between the two technologies can be good from energy efficiency perspective as well. For example, some applications which are offloaded to Wi-Fi compared to the licensed spectrum can be more energy consuming if comparing the fact that, okay, UMTS 3G is less energy consuming compared to OFDMA. So Wi-Fi is OFDMA.
yeah, right,
So
right.
means there needs to be a study. I mean,
In terms of the energy savings.
Energy savings
Yeah.
when to offload. Is this in the agenda?
No, not at the moment, but yeah, that's a good point. Yeah, there may be energy
Because-
considerations
Because
as well.
different RAD technologies have different energy footprint.
Yeah, yeah, definitely. Yeah.
So
What I do remember is that you know, there is a femto awareness thing, right? Suppose you come to a femto area and then and then if it is femto and Wi-Fi together, right? Then you know there's a Wi-Fi access point there that can be used to turn on the Wi-Fi radio in your handset. So the premise is that if you leave your Wi-Fi on all the time, there's going to be a lot of power drain. So if you want to avoid that, how do you turn it on without user intervention, right? So one idea would be, I mean, femto is always on, right? So when you come on, so the Femtocell recognizes you are there, and if there is some, you know, signaling, you know, API, then that can be used to turn on your Wi-Fi. So, you know, things like that.
Okay.
So then we said, okay, let's start looking at, I think I have to rush a little bit now. We defined a work item to look at the network aspects, right? Not just the radio aspects. And because we didn't know too much about it, we said, okay, let's make it a comprehensive white paper that looks at the business aspects and the management aspects, that is the provisioning and, you know, monitoring and troubleshooting, those kind of things. And then traffic management, you know, between the different radios. And then finally the policy that will be used, that the operator can use to actually do this traffic management. And this is, as we speak, getting the final quotes and then should be ready pretty soon. And I know that Simon, chair of Femto-Forum, is also very anxious to make a statement, if not release it pretty soon. So just to give a sense of what is in the white paper, because it really captures all that we did. Of course, there's some initial background on 3GPP and Wi-Fi and enterprise networks, but then we looked at residential, enterprise, and metro integrated Femto-Wi-Fi networks, and looked at, first of all, the business aspects in terms of what are the benefits to the user and to the operator. But also, we looked at, you see, in all these scenarios, there are multiple stakeholders. You, of course, have the mobile operator, who owns the femto mostly. Wi-Fi is a question mark. The user may own it, the operator may supply it, or now there is the backhaul provider, right? It may be provided with a backhaul provider. And there are many combinations in terms of, you know, who owns what and who manages what, right? So that leads to several, you know, what we call like operational scenarios. So we kind of try to, you know, identify all those and then talk about them a bit. And once that is done, we have a section that deals with the technical and service aspects. So as I said, first is about the provisioning and management, and then the traffic management. As I said, you know, you can have smart offloading based on, you know, location, user type, traffic type, and network conditions. Seamless handovers. So this is active mode handover as opposed to the first one. By offloading, I mean a idle mode handover, if you will. And the third one is really the simultaneous attachment. If your UE is simultaneously connected to Wi-Fi and cellular, what are the things that you can do? So you can do, for example, flow mobility. So some applications may run better on one radio as opposed to the other, right? So so that kind of segregating flows to different radios can be done. Aggregation can be done either for increased bandwidth or for resilience, etc. Then LIPA and SIPTO are two terms from 3GPP standards. The first one stands for local IP access. The whole idea is that, and I think it was in one of the slides this morning, but if I'm camped onto a Femtocell, which could be that box there, right, and I want to access a local printer, it makes sense to make a local connection as opposed to going all the way to the core network and then tromboning back. So that's called local IP access. And and SIPTO is, by the way, so that's the basic local IP access. Now in an enterprise environment, for example, where there are multiple Femtos, what does LIPA mean? Well, I'm in this building, your office is in 2 buildings away or something, and you want to print it there or you want to access something. So you would want to extend the concept of local IP access across multiple Femtos. And there are interesting variations in terms of how you can do that. SIPTO stands for Selective IP Traffic Offload. So it's basically offloading of traffic selectively, and I have a picture that explains it better, but it's basically offloading the core network. So the idea is that if I'm browsing the internet, let me say 1 or 2 sentences. See, at a very simplified level, there are 2 types of services that the UE can be getting. One is those provided by the operator, and those that are public internet kind of services. If it is services provided by the mobile operator, you have no choice. Your pipes have to go all the way to the core network. But if it is public internet content, then there's no reason why you have to flood the operator's core network. So that is basically the selective offloading. And then there are interesting questions that follow from that. Which is the point of offloading, right? Ideal would be if I can offload directly at the access point, because it doesn't have to go any access point, meaning in the broadband network, the IP network behind it, right? If for some reason, but that requires a cooperation between the broadband ISP and the mobile operator, right? Because after all, the traffic is originating on a mobile device, and you want to offload it from within the broadband network, so you got to have some cooperation between the 2 operators. If you don't have that, then it will still have to go to the core network, but at the entrance to the core network, you can offload it. So that way, at least you can save the traffic from flooding SGW and PGW in the EPC world. Policy and control, a very hot item right now. A lot of operators, they basically, we all seen those curves, which are, revenues are flat and traffic is exponential and so on. So the operators are certainly trying to use exercise different policies to limit the amount of usage or charge differently and so on. So it's a very important activity that's going on right now. And then we looked at some of the architectures, and here the thing that we were focusing on is, see, I can say it in very simple words, right? See, we're talking about integration of Femto and Wi-Fi. The question simply is, where is this integration going to take place, right? Now, granted, you have a single box with the 2 APs. So one integration point is the AP itself. The 2 radios come together, and you can do all the flow management, aggregation, whatever. But you don't have to do that. You can simply treat this as, as an efficient implementation of an integrated modem, but the data pipes go all the way into your core network, and you use today's solutions, which are IWLAN and the EPC solutions. So in this case, the integration happens at the PGW or the GGSM. So these are 2 extremes. One, you do it at the customer premises, at the small cell, or the other, you do it way at the operator edge node. Or there is an in-between option, and that is the gateway. Small cells and femtos, they'll always have these controllers and gateways. So that can be another interesting point to offload. And it's interesting because if you are at the gateway, you have visibility to many APs. So you can do more clever management across all of them. Compared to if your integration is at the edge, you are limited in terms of what you can do. So those are the three architectures that we kind of looked at. Okay, and so I have slides that talk about all this. So, well, this is, I think, something you all know, Femtocell network architecture. Just a slide that shows, the Wi-Fi side of it. Sometimes, at least those coming from 3GPP side, we show a handset here, we show the mobile core network, and we draw one cloud for the IP network. But actually, if you talk to people that provide that IP network, it's a lot more complex, So you have this wholesale broadband part, and you have the ISPs, and that's actually the reason why, and I think it's more and more important to understand this broadband network that sits behind the APs, and actually to model it. And therefore, there was a model that was shown this morning, the backhaul, there's a DSLAM and a brass and all that. So I think it's increasingly important for all of us to understand and model the backhaul and take that into account in our overall system analysis. I'll skip this slide. I think I've gone through this in some way. Then we looked at residential and the different things, and we came up with different operational scenarios. This is what I was talking about, right? So, for example, if the MNO provides the Femto-WiFi and the broadband, for example, Verizon does in the US, right? Then you have one kind of a scenario, one set of possibilities. On the other hand, in this case, the MNO probably provides just the Femto and the broadband, and then the Wi-Fi is by the customer. Things like that, Now, the general opinion seems to be operators don't want to manage the Wi-Fi. They want to sell a box that has Wi-Fi in it, but they don't want to be responsible for managing it. Enterprise, the only difference is that you have a Wi-Fi network and there's a Wi-Fi controller on the premises, right? Whereas the Femto controller will be back in the core network. So that introduces some interesting problems in terms of joint management of the Wi-Fi and the Femto. And in the metro case, here the Wi-Fi controller and the Femto controller are both in the network. So in some sense, you don't have that problem as an enterprise, but still there is a problem, and that is the place where they are located are different. The Wi-Fi controllers usually are closer to the edge compared to that. And the other thing is also the protocols used are different, and I'll come to that in a second. So if you look at the provisioning of Femtos, it's done through TR69 protocols, whereas the Femtos are usually provisioned using SNMP protocols, right? So how do you, you can say, well, the operator just manages them independently, that's fine, right? But if you want some kind of integration of the two, clearly there are some mappings and translations that need to be done between the two protocols. Okay, so this is a busy slide, but basically it tries to show the possibilities in terms of the traffic management, right? So you have a dual mode UE, a FAP and a Wi-Fi access point. You're going through your broadband network. This is your Wi-Fi chain, right? Obviously, we're talking about operator managed Wi-Fi services, right? And these are 3G terms, but there are corresponding ones for 4G as well. And the top one is the cellular part. And here is your GGSM, or the PGW in this case, which takes you into the operator services. So in this picture, what we're saying is that, and there are solutions already in standards, in 3GPP standards, which talk about how to manage cellular and Wi-Fi at the GSM level. Okay? And as I said, that's the IWLAN and the EPC. And there are many protocols, DSMIP, PMIP, and GTP. So here you're not exploiting the fact that one of these is actually a femto link as opposed to a macrocellular. See, this works fine for macrocellular and Wi-Fi integration. But if it is co-located, there must be additional advantages which are not taken advantage of here. So, as I mentioned, one extreme way of exploiting that is to put in the integration function right at the edge in the small cell, and the other variation is to have the integration done at the gateway level. This being the femto gateway, and this is a corresponding one on the Wi-Fi side. I apologize, I'm going a bit fast, but I'm conscious of the time. So, in terms of the policy and control, the key point is that 3GPP has standardized what's called ANDSF. Stands for Access Network Discovery and Selection Function. So there is a ANDSF server that stores the operator policies, and the UE has a client, and there are protocols defined for downloading the policies from the server to the client. And those protocols are OMA DM. DM stands for Device Management, and OMA is the organization that standardized them. So using the ANDSF server as the database, and they call the management objects, and using the OMA DM protocols for communication, the operator can push his policies onto the UE. And these policies generally have to do with how to use Wi-Fi. Okay? And that really underscores the whole solution, because right now the user makes the choices in terms of the Wi-Fi usage, but the operator wants to be able to control that. So this is a framework that provides that. So what additional things? Now this is going on already in 3GPP with macro and Wi-Fi. If it's femto and Wi-Fi, what additions can you do? So for example, the discovery of cellular and Wi-Fi can be combined now. Because if you have discovered a small cell, if there is some way to indicate that it's an integrated modem, then you also have discovered Wi-Fi. So again, leveraging and exploiting the fact that one implies the other. See? So those are the kind of things that we looked at and documented. These are some of the standards that are going on in standards activities in 3GPP. As I mentioned, IWLAN and EPC are the basic ones. Yeah. So the only thing I can mention is this is very important thing that's going on right now. Hotspot 2.0 is trying to bring, and I think there was a slide this morning, is trying to bring the level of seamless mobility to Wi-Fi networks, which we take for granted in the cellular networks. When you move from cell to cell, you don't do anything. The handset and the network take care of it. Wi-Fi, it's not like that, right? So the Hotspot 2.0 is a WFA certification program, which basically allows seamless roaming.
Isn't that a danger to femtocells? Because one of the the beauties of femtocells is that you got all the roaming, the handovers, etc., really sorted out historically, and now IEEE is also shooting for that with the Wi-Fi access points. So
no, it's only good actually, because you see, if you take example of AT&T, right? You're an operator and you're deployed your hotspots, and you have your regular network. Right? Mm-hmm. Now, I mean, why wouldn't you? And maybe you want to sell your Wi-Fi hotspot service to another operator who wants to use it. Right?
That's it.
So no, I think I mean, by the way, very recently a paper has been done by GSMA WBA on this roaming. No, I think it is just to the benefit of both. Yeah. But there is what has been agreed upon is just the first step. I mean, there are more things. So, for example, just the discovery and access authentication. Those are the only two things that have been addressed so far. Okay? But once you have discovered and once you've been authenticated, then comes the policies. Right? 3GPP has advanced a great deal in definition of these policies and all that. IEEE and WFA, they have not. So it will be interesting to see if WFA can adopt some of the 3GPP ANDSF solutions, for example. Okay, I see that I'm right. We're out of time. Okay, so I think that at least brings me to the end of the IFW work. You know, there are a few slides. There's not too much I wanted to say on this, but you know, Femto services is a very important development, and as I said, you know, the operator would like to sell not just a box for completing calls, but you want the user to be able to do additional things. So you know, Femto-Forum has been very active in defining APIs. These services can be on the UE, they can be on the Femtocell, they can be on an application gateway or in the core network, and these APIs have been defined, and I think it's a very important development with a lot of hope. Of course, you know, the forum and the industry should really push and leverage this and make it like Android apps or Apple App Store. You know, I don't think it'll reach those scales, but at least I think it should be. You know, so there are some. There's not too much text here. There's just different types of APIs. So this is an API where the applications are tightly integrated with the access point. And then there is a case where there's a loose integration, in which case you kind of need this sandbox around the application. And the third scenario, of course, is where the application sits in a separate entity altogether. So you need an explicit external interface. And you know, just three different types of applications, types of APIs. So here, the first type, the UE can actually demand bandwidth. You know, so they've defined APIs for talking to the AP to get more or less bandwidth as needed. And then the second set is in the group of signaling APIs, where the AP can initiate calls and text messages and things like that. And the third is where the AP can be a node for managing the customer experience. And this is a very interesting one, because see, right now, the network, if it wants to know the user experience, you know, it doesn't have many tools to do that, you know. Whereas with a smart edge node, the edge node can collect a lot of statistics about the user experience, even dropped calls, or you know, a lot of knowledge that can be gathered and then supplied back to the user. And there's some example, and this is the set of all APIs that have been looked at. So that's it. Thank you for your attention.
So any questions before the coffee break? Yes. Wait.
I thought we were out of time. Only a question, okay.
Did you discuss in the forum the pricing models for the Femto cells?
No, they generally are out of bounds, you know, because there is even some antitrust things and all that stuff. So generally there is a explicit warning that there should not be any discussion of those things, because you can get into antitrust problems, price fixing.
Okay. And what about the cooperation between Femto cells and the normal cells?
You mean macro?
Yes.
You mean cooperation meaning? I mean Femtocell is part of the macro network, right? So
yes.
In some sense, you know, the cooperation is assumed. I don't understand what you mean by cooperation.
I mean, it can be when you have the macro, can use can benefit from the femto when the femto is more useful
yeah, I mean those would be policies, for example, right? I mean offloading is an example, right? I mean if I'm understanding you correctly,
yes,
the operator can supply policies that will govern the user from logging on to femto as opposed to the macro.
yeah.
Those are possible. Yeah.
Okay, thank you.
Yeah.
Okay, so I'm really interested in this interoperation between Wi-Fi and LTE and these femto cells. So I have been paying a lot of attention to what you were saying, and I was wondering continuously if all the discussions you're doing at the Femto-Forum can be directly applied to the macrocell network. I mean, is there any fundamental difference in terms of interoperability between Wi-Fi and femtos different to Wi-Fi and macrocells?
Yeah, that's why, see, all the solutions that have been developed for the macro see, the IWLAN, EPC standards, they've been defined for macro cellular networks and Wi-Fi. They can all be used for Wi-Fi and femto. Why? Because femto is like a base station, right? It supports all the same protocols and all that. So that is this, right? So the blue path and the red path go totally oblivious that you are in a femto environment, and you have, for example, a DSMIP entity there and a DSMIP entity here, for example. Everything can be done, right? However, you are not exploiting the fact that now in the macro network, the macro base station and the Wi-Fi access point, they're geographically different, right? And that's why you have the only logical place where the two links can come together is the PGW. But if you're putting them in the same box, they are right next to each other. So they're co-located. So the natural question is, can you reap some benefits from it?
So at the Femto-Forum, you're focusing on these benefits that you can get from the co-location? Sorry. So at the Femto-Forum, you're just focusing your discussions on these potential benefits of having the devices co-located?
That is one, that is as far as the traffic management is concerned. But say, for example, the provisioning is another thing, right? See, if the operator is providing the Wi-Fi access point, say in a metro, in an open metros, right? In a small cell on a lamppost, you're the operator and you got your small cell there, right? You want to be able to provision and manage that box, right? Mm-hmm. How do you do it in a joint manner? Yeah. So that's also of concern, right? Mm-hmm. And then policies, as the gentleman said, right? Do you want to come up with policies that are unique to femtos? Mm-hmm. So it's more than just the traffic management. In fact, I think this traffic management will probably come last, because I mean, if you are the operator, what will be your attitude? You first want to get the thing running. You want to be able to deploy it, manage it, and put in the right policies that people use it in the right way for the right things. And then you want to be able to do additional things, right? Yeah. You can't do all the smarts without having these in place. Mm-hmm. But I feel that this edge-based solutions, from a research point of view, so if you're all trying to do advanced research that can one day become standards, for example, right? I think there is a lot of opportunity for doing smart things there. Even policy, for example, right? See, policies reside in the core network. But if you have an intelligent edge and you have a local policy here, so you cut down the signaling traffic to the core network, right? So number one, how do you design a local policy engine? Second, you don't want that local policy engine to be totally out of control from the mobile operator perspective. So you want some kind of a hierarchical operation, right? In fact, you can look at this as a good example of a hierarchical network. not just from coverage point of view. If you look at 3GPP hierarchical cell structure, it's only from coverage. But think of that smaller one as much more intelligent, much more capable, multi-technology, right? And now you want to operate that in the big network. How do you do this in a standardizable, efficient manner? I think there are interesting questions.
Thanks.
Referring back to Thierry's slide, InterDigital seemed to have a lion's share in LTE technology. So means
not my slides.
no, means his slide. So means it would be good if you could shed light from industrial's point of view, what has been done based on and what is left to be done. For example, this smart offloading and vertical handover between the technologies. So, being a member of Femto-Forum, definitely the recommendations are there, and there is a vision that this should be achieved. But in terms of industrial achievements, how much of that has been achieved? What is left?
In terms of open problems,
for example, some load balancing solutions are already there in, for example, Motorola's base station, and also in one of your slides you mentioned that femtocells won't give us the advantage that they won't have power consumption.
Yeah. I think one of the things that comes to mind is the hotspot 2.0 and the 3GPP network integration, ANDSF integration, because at one level they are trying to solve similar problems, but they're still very different, And so, for example, I mentioned that management object. That's the term they use, MO. That really encapsulates all the policies. The structure of the MO in the ANDSF and in hotspot 2.0 are apparently very different. So that's just one example. But the second thing I mentioned also is that 3GPP has done a lot more in terms of standardizing policies. They call them ISMP and ISRP, inter-system mobility policies and inter-system routing policies. So, and the protocols are there. I mean, hotspot 2.0 hasn't even looked at any of those. So, how to come up with. So, I think policy control, joint policy control is an important problem.
So, means in a nutshell, who is following who? Means industry is following Femto-Forum, or Femto-Forum is kind of embodying what has been done, industrial trends.
I mean, it's a bit like what Thierry was saying. We of course don't want to propose something that is so orthogonal to. So we want to build on what standards have done, and then try to propose something different. So for example, if we come up with some ways of doing this edge-based processing, for example, there's no reason why we couldn't take it to 3GPP.
A small question.
Yes.
Last one. Does Femto-Forum put any list of applications of Femtocell? Means you said that applications are very important. So did they manage to put a white paper on that?
Yeah. Services, actually they have released an API specification white paper, I think even Femto applications also there is a separate white paper, I think, yeah.
So only accessible or only for members?
I don't remember right now. Yeah, send me, actually, for any of you that would like more information on any, as someone mentioned, I've been saying white paper for everything, So, please send me an email with what interests you, and I will, and also please indicate if you're a Femto member or not. And if you know, if you don't know, I can check it up and then let you know and send it back to you. So please, my email address is somewhere. I look forward to any feedback. Yeah.
Thank you very much.
Okay.
Thank you.
Was it all right?
That was very good.
Okay.
Yes, excellent. I was a little bit afraid that you get very much aligned with Thierry, but in the end it was really very complementary. So it was perfect.
Yeah, yeah.
Did you quote it with him, or did
No.
you quote it from?
No,
Okay.
no, no, no.
It was just perfect. Okay, okay.
Yeah, yeah. But it was at the right level of depth
Yes,
and breadth.
yes.
Okay.
It was very good, yes. I think our business people were taking notes. So this is
Okay,
very good.
okay,
Yes,
okay.
yes, yes.
Okay, well, I'm glad it. I know I ran out of time a little bit, but hopefully
No, it
not
was
too
very
much.
good.
Yeah.
You know, we started a little bit later, so
Yeah, yeah.
then